Take it away, Ken.
All right. Good morning. Thank you. Thank you so much for having me here. Thank you to Alan and Mid-Atlantic Chapter and the Alliance for hosting the webinar. It's a pleasure to be here. I did drive down this morning. I'm fully caffeinated, though. But I may be moving a little fast, but there's a lot of material to cover this morning. And what I'm hoping is maybe at the end, if everybody could jot down their questions, and at the end we can circle back through. So we can be sure to get through everything in a pretty timely manner. 475 High Performance Building Supplies, my company, myself and two partners have Passive House training. We come from Passive House backgrounds. And really the impetus of the company was to bring in materials and systems and thinking about bringing design, construction, and high performance together. Our work is born out of the desire to see successful Passive House buildings, but we also consult and provide products for a range of performance levels. We're always trying to push them to higher and higher performance. So with that, going forward.
Yeah.
Okay.
So, just
So the
down button.
The page down?
Yeah.
Okay, perfect. So with that, we'll quote our friend Joe Stiebrick, that today's walls and roofs need 4 principal control layers, especially if we don't build out of rocks. They are presented in the order of importance: a rain control layer, an air control layer, a vapor control layer, a thermal control layer. A point to this importance thing here: if you can't keep the rain out, don't waste your time on the air. If you can't keep the air out, don't waste your time on the vapor, and so on down to thermal. Now, most people are pretty familiar with rain control, more so about thermal control, although with Passive House, we're lifting it to new levels of continuous insulation and thermal bridge-free construction. But really the air control and the vapor control are more mysterious to most people and where we're really focused on. Now, with the Passive House crowd, air control is, again, much more on everybody's mind and a big part of the focus, and is really the focus of our company, hand in hand with the vapor and moisture control properties. So we start part 1, the importance of air tightness and how to achieve it. Again, some of this is going to be basic, but we'll move quickly. So the importance of air tightness: indoor air quality and comfort, insulation energy, bulk water vapor. What do we mean by that? Sorry, this is all going up a little dark. I guess on the computer screen it's more accurate. A prerequisite for indoor air quality and comfort is air tightness. So this is New York City, air filter in New York City after a few short months, completely full of soot of incoming air. So if the basic concept, which we're all familiar with, I think, if we want to control the quality of the air, we need to control the air. So air tightness is providing us the control so that we can, the pollutants can be prevented from entering and indoor toxins can be predictably removed. And as far as comfort, air tightness is important in terms of comfort for eliminating drafts. Basic stuff. Air leaks compromise the effectiveness of insulation. Now, this is something where it gets a little bit more esoteric, where if you want to imagine, if you have a fibrous material like rock wool, fiber, spun glass, insulation, cellulose, like a thick wool sweater, unless you're providing an air barrier around all 6 sides of insulation, you're not getting optimal insulation. It's like you're out in a cold breeze in a thick wool sweater without a windbreaker on. You're going to be cold. Once you have the windbreaker on, the insulation can do its work properly. So if so if we want to if we want to optimize the insulation we're putting in the building, we need to surround it with air tightness. And Proclima, the manufacturer that we represent from Germany, has studies done with the Institute for Biophysik in Stuttgart a factor of 4.8 difference of the thermal value of insulation between airtight or not. So the thermal value is huge. Air leaks allow bulk water infiltration. So this is a famous diagram from the Building Science Corporation. Their document insulations, sheathings, and vapor retarders. If you haven't read it, I encourage everyone to go on their website and download it and read it. And shows a very telling example that with a 4x8 sheet of drywall, through diffusion, you're going to get a quart of water. I forget what the time period is with that. One heating period. So over the course of a winter. And then if you have a 1-inch square hole in it, you have 30 quarts of water. So that is a tremendous factoral difference, and is why even if you have vapor open construction, if you have air leakage bringing in bulk water vapor, you can still end up with problems, even if you've done everything else right with the vapor profile. So with that, there are more moisture-related failures resulting from air leakage than from diffusion. Everybody worries about diffusion in terms of wetting, but it's really the air leakage that is our biggest problem in terms of the wetting of the assembly. We'll talk about the vapor diffusion in terms of drying potential in a few minutes. But so we can look at air tightness as, think of it as an insurance policy. And the greater the air tightness, the better the insurance, the better protected you are going to be against these moisture problems, against energy losses, and against poor indoor air quality. Assuming, of course, we do a number of other things right along with it. None of this is in isolation, as we well know. Fully integrated building approach is important. And so I'm assuming a few things along the way here with our audience. So how to achieve proper air tightness? As we know from our training in Passive House, we want the continuous air barrier, not lifting the red pen off the paper, is first and foremost conceptually. We want to have, so this is one of the mock-ups that's in the room here today. We want to, if we have a dense packed cellulose wall construction, this is showing a dense packed cellulose between 2x8 wall construction, plywood sheathing with rock wool insulation, and then a weather resistant barrier. If we want to optimize the rock wool and the dense pack, we have an interior air barrier, airtight layer, which is our product Intello Plus by Proclima. And then we have an exterior wind-tight, airtight layer protecting the fibrous insulation. This is another mock-up that's in the space. Here we have dense packed cellulose with the product DB Plus, which is a paper-based reinforced interior air barrier. Very sustainable product that is vapor variable. We'll get into the vapor side of it in a minute. With Mento Plus, Solitex Mento Plus on the outside, which is reinforced weather-resistant barrier fabric. So it's airtight, it's waterproof, and it's vapor open at about 33 perms. And in this particular construction, we're showing a double stud thick wall cavity with cellulose as needed without sheathing. The racking structural capacity would come from the framing elements, diagonals within the construction. So you have continuous insulation as well. But again, we're showing fibrous insulation, important interior, exterior. So here's the interior airtight membrane in an installation, which is the Intello Plus product going all the way around. Exterior, wind-tight, airtight membrane. So once you have the continuous interior airtight membrane and the exterior, one thing that's very crucial and to think into the planning along the way is to protect these airtight layers. And so we very much encourage a service cavity on the inside of the construction, on the inside of the air barrier, and a vented rain screen on the outside. And both of these provide space so that from incidental uh, damage during construction throughout the longevity of the house, you're going to have a more robust, long-lasting airtightness to the construction. Here we have the service cavity at the interior, and we find it very useful. Sorry, this is jumping ahead twice every time I push it once. I'm really not making the same mistake every time intentionally. Um, so here we have the interior service cavity. You can see with lots of plumbing lines for electrical lines. We have horizontal battens. I think this is 2x3s. About 18 to 20 inches on center. This also helps hold the dense packed cellulose in place over the long term. Uh, that goes. Uh, Here we have the service cavity at a cathedral ceiling construction. You can see the detail there. And then the rain screen at the exterior. So you have, it's a little hard to tell. I'll jump ahead. This is similar construction to the mock-up where we have plywood sheathing with the rock wool on the outside of it, and then covered with vertical wood strips, furring over the Solitex Mento weather-resistant barrier, um, so that furring is providing the protection. The rain screen is providing the protection. Another important thing that we need to consider more, and anyone in the middle or trying to execute these projects and getting airtightness realizes that the critical junctures and the sequencing of what we're doing and the ability to not only not create more headaches for ourselves in the construction process and create finding ourselves really with almost unsolvable airtightness problems, but planning ahead and getting in front of them, as it were. A big thing is the joists going through the airtight layer, and you want to keep the joists inside the airtight layer. But we also want, ideally, again, we want the airtight layer on the inside of the insulation. Um, so here we have the fabric that is bridging around the joists from the first floor to the second floor. So one can imagine, I don't have a sequence on this, but building the first wall, laying the fabric over it, and then placing the rim joist in the second floor framing, flipping it back in, applying the second floor framing, attaching it back, and then continuing with the airtight membrane. So you have a continuous there. This hard to see here. I think on the computer it may be okay. This is a construction where we have an I-beam going across a cellar space. I believe this is the underside of the first floor that they're making airtight, and they're placing new joists or reinstalling joists over the I-beam. So they draped the Intello membrane over the beam before placing the joists on top, setting up the sequencing. Makes all the difference in the world uh, to get rid of complex geometries. This is another approach that we've found and spoken with this architect, Gregory Laverdera in New Jersey. Excellent website. Encourage everyone to go check out his work. And what he's trying to do is sort of I think he's calling it a modified Swedish framing system, where you can see the uh, continuous air barrier is going from the foundation all the way up, uh, where the framing above and below is in line, and they've just applied a ledger to support the second floor, and super clean airtightness. Here we have an example. A lot of us are using OSB, plywood, and other rigid sheathings for airtightness. And I should say, we have tapes and products that complement all those different approaches approaching airtightness. So you have Unitape by Proclima that we sell on OSB plywood here. Then you have a connection from the OSB to the concrete floor with a strip of fabric going to the concrete floor. Now, the connection oftentimes can be a little dicey, if you will, from a rigid or a membrane that's made for airtightness to masonry that isn't ideally um, finished for airtightness necessarily. It can be rough. And so here we actually have the sample here in the room. You have a, Roger. Um, there you go. You have the Solitex membrane, exterior membrane, and this is a caulking adhesive. So it's a acrylic-based adhesive where you're bringing the membrane of the airtight layer up to the masonry, rough masonry surface, and you need to get in the nooks and crannies. This caulk will provide that connection. It won't dry out over time. It retains its resilience, and it's quite strong, as you can see in this picture here. And it's here in the room for folks to test. They've actually already tested it here. So this is an important juncture that all too often, we end up scratching our heads or letting the sort of unacceptable leakage happening there. So this is a slide we have from Roger. I think we have a few of your pictures, Roger. Thank you. Uh, so we have this continuous airtight layer. We have it protected. We have it sequenced. We've thought through the way to do it. Now, all of a sudden, we've literally got 1,000 holes through, or at least 100 good holes through this air barrier. So we've got windows, we've got doors, we've got pipes, conduit, wires, ducts. And really making sure that all these holes are taken care of is integral to the airtightness, preserving the airtightness of the structure. And the key thing about what we're supplying and dealing with is the Proclima line of products with the tapes and the gaskets, the caulking adhesive, the primers. They really get you to the finish line in dealing with all of these unique situations that we'll see here. So Roger has an excellent blog post, which I'm sure most people know about, testing different ways to seal a window. So this was an OSB construction where I think he had Vanna tape around it. But we would recommend using the Profil tape, which is a split back tape. So you can apply just a small half-inch narrow part of the tape to the window frame, and it keeps a low profile. So then you could imagine sliding a piece of sheetrock or finished wood material, and it will cover that edge of the tape that's face taped to the window frame, and then you can come back later and remove the rest of the backing and apply it to the airtight layer. Here we have a connection. This is a masonry building, a brownstone. Sorry, I don't know how this is going two at a time. Is this just?
I don't know. I'm sorry.
Okay, as long as everyone sticks with us here.
Actually, since we broke the momentum there for a moment, I want to just make a comment and apologize for those of you watching this via webinar. Because we're presenting and projecting off the same computer, webinar captures and broadcasts my screen, which for Ken and I is the control panel for PowerPoint. So you're seeing the slide and the next slide and the timer, etc. So I apologize for that. Perhaps I can minimize some of it. I did try to get rid of it, but I'm afraid that's just how the technology is going to work in this case. So I apologize for that, but I think you can still see the images, and we'll just soldier on.
Sure. We're happy to make the presentation available to anybody who wants it. They can go back and take images. So here we have masonry construction, and what we're doing is taking the membrane and bridging at the window pockets to make sure we get a good seal to the window frames. So because those joints are very messy, so you have a membrane going around, taped to the window frame, and then attached, adhered to the masonry around that. They were using Stogold product there. It's hard to see in the projection here. This is I guess it's going two at a time because it's going two at a time. Maybe, I don't know.
I'm sorry.
Anyway, that's all right. No problem. So this in the room it's hard to see, but I think on the computer screen it's okay. On the right is a skylight in a ceiling construction. Again, similar thing where you see the diagram. We have the membrane reaching in. Very simple approach to integrating the skylight. Big thing, don't tape to dust. We can't have construction sites are not dust free. So, nobody would ask for that. But it's important that the workers, as they move through, do uh, brush off and get rid of most of it. So it's a reasonable surface that you're taping to. And then we have the foam experiment. And the thing about foam is it can look really airtight and be convincing, but with the blower door test repeatedly, it's completely unpredictable. Um, and so we definitely recommend to not use foam and not surprisingly use our tapes and gaskets. Um, we've just found repeatedly that it's shrinking. It doesn't expand in the direction that you necessarily want it to. You could have the cleanest looking, most beautiful job in the world, and you blower door it or image it, thermal imaging, and you find problems left and right. So here we have is the repair job that Roger did, I think, on that one, and with the tapes in the location. And one thing um, if you can plan it is to the degree that's possible, give yourself room. And it's one of those things you're always asking the construction crews to go another step than maybe they're capable of that moment. But as long as we keep pushing forward, and the key thing is to really allow room at the penetrations, pull it away from the edges of stuff. Everybody's used to sticking it in tight and in the corner. And this really takes a different approach. You need to be able to get around the entire penetration and get it clear. So on the right, we have an inlet and exhaust of HRV setup. And what you're seeing are two EPDM gaskets, the Rowflex gaskets that we sell that are then taped into the membrane. And you just give yourself space and you have a nice, complete, verifiable seal. Similarly, with wires going through, there are single patches, there are double patches, there are multi patches where you have wires going through. A very clean and straightforward way to have your penetrations, and they will last the lifetime of the building. These aren't things that are going to dry away or become brittle over a few seasons. This hard to see here. This is just a vent pipe going up through a Intello in a ceiling, and you see the diagram to the left illustrating it. Again, it's a EPDM gasket on the pipe, taped to the membrane, verifiable. Flexible tape. So this is TestCon #1 tape that we sell, which is a highly flexible, airtight, same adhesive um, uh, that can help you do a lot of the things that you may not necessarily want to or need to, or just uh, or you may not have a gasket, whatever it is, that this tape allows you a robust way to address it.
Try using this one next time.
Okay. Oh, right, because it may.
Maybe, yeah.
Maybe. Here we have, yeah.
That's you didn't do this one yet, right?
Right.
It wouldn't focus. Okay.
So, oh, right. Perfect. So here we have a really common problem in New York, and I think it's so the first one. Here we go. So these are joists, floor joists going into a brick wall, existing old retrofit building. And so here we have some felt tape. It's adhered to the wood around and then laid on the brick. And then they've actually plastered over the tape and integrated the tape into the brick and then continued the plaster down the wall. So now you have a completely integrated, now it's just going.
Sorry.
It's all right. Let's see if this stops here. So that's the completely integrated. Another approach might be a hard, rigid air barrier. And then you have the tape going around that. And again, the profile tape, which is the split back tape, is what we recommend when you're inside corners like that. So you can apply it to one side and come back and then apply it to the perpendicular surface. Right, and that's what we've got here. Roger just picked up.
So that allows you just to get a cleaner, straight tape because you're only having to worry about one adhesive surface.
Right,
So you
sticking
get
at a
it straight
time.
and
Right,
then peel it off and attach it to the next surface when it's
right,
already applied straight
right. Because oftentimes you end up sticking to the other surface before you're
by
thinking about the
accident.
other
Yeah, right,
surface.
right.
And you can put this on the windows first before you put it in, right?
You could,
Mm-hmm.
you could. The SL, which actually, which we'll look at in a minute, which is another way to tape the windows. We typically see that being taped on first. And if you do the face taping of it with the profile, we typically would do that after you install the window. Only because you can. The other way to do it, where you're taping around the outside of the frame, um, uh, you can't get to it once it's in. So here we have another way, a membrane going up as well and taped around. So any number of ways to do it, give you a good seal. It's no end of the headaches of these existing penetrations into the brick walls. So successful air tightness, we're optimizing the insulation. It's continuous. It's sequenced properly. The penetrations are clearly addressed. We protect the airtight layer with preferably service cavity and a rain screen. And we use flexible and durable materials to do it that aren't going to dry out or be compromised over time. So vapor control, diffusion. Yeah, how are we doing with the time? It's 30. Oh, that was
You're
about
fine.
it. Yeah, that was good. We're moving. So vapor control, diffusion, um, and how to control it. So the big thing about diffusion is not so much the wetting, but it's the drying. The enclosure is going to dry through diffusion, typically. Um, and so we want to minimize the wetting, of course, but we want to maximize the drying and do that by controlling the vapor. And so the first thing to acknowledge is vapor is complex, way more complex than air. And I'm not going to answer all the questions here. I've got, but we'll at least get the conversation rolling and see how we're addressing it. So as we know, wetting can cause rot or mold. Classic photos left is from Green Building Advisor, where this is bulk air vapor from an air leak. This is not diffusion uh, uh, rotting. And then, behind any vinyl wall covering in an air conditioned building, typically there's some level of mold behind it because it can't diffuse, it can't dry out through the vinyl wall covering. So it's sitting there. Typical problems. So as we said, the enclosures dry through diffusion. So to maximize the drying potential, we want to dry in and out. Um, Dry to the exterior, typically in the winter, and to the interior in the summer. And I know as the north becomes south, we'll have more all we'll all be living in air conditioning climates soon enough. But we still need to deal with the cold climate issues as well as the warm climate, and we'll discuss that a little bit. One thing that's really important to note that people don't, I think, often consider, and is sort of the leading issue to later building failures, is that the enclosure may come loaded with water. And so in the construction process, we've all seen construction sites just absolutely soaked uh, one way or another in the material. It's all closed up and it all looks good and everything. But depending on how we close up that assembly, then if we're sealing it in with vapor closed materials, that moisture, all of a sudden you've got like a time bomb just built right into the building. Um, so we want to be cognizant of that, that you may be starting from behind the eight ball already. Uh, so the component permeability we need to consider. So this is all part of the complexity thing. You need to, where's the vapor barrier, or where's the vapor barrier? If there is a vapor barrier, where is it? What's the different uh, permeabilities of the materials? Three classes of vapor retarders: impermeable, semi-impermeable, and semi-permeable, and then vapor permeable materials with different examples of each. So we're all considering that in doing the assemblies. The hygroscopic properties. Here's another advertisement for cellulose. Cellulose is a wonderful material that wicks moisture, moving it from the wet spots to the dry spots. It really helps actively maintain the enclosure. Foam is awful in dealing with moisture. It's just a dam. And bats aren't great like cellulose, but they're not as necessarily as bad as foam. Um, so you want to consider that in how you're going about the enclosure. The temperature gradient and dew point. This is quote Martin Holliday from Green Building Advisor. The main reason to perform a dew point calculation is to determine when there's no internal vapor barrier whether the exterior rigid foam is thick enough to prevent moisture accumulation in your wall sheathing. So there's a couple issues with it. So the diagram on the right shows wall construction, wood wall construction, where the relative humidity inside is 50%, 70 degrees inside, 0 degrees outside. And so the dew point's at 50 degrees Fahrenheit within that wall construction. And so the location of the condensation is going to be on the back side of the plywood within the wall construction. And we've all seen the pictures, I think, from Building Science Corporation with the frost on the dramatic pictures of the frost on the back side of the sheathing. Um, uh, and so the question is, and this is obviously the way Building Science Corporation approaches a lot of it is, well, the issue is, well, how much foam do I need to add? We'll just wrap more foam around the house. And so our question is, well, what if I don't want to wrap foam around my house?
Thank you.
Then how do we build a high performance enclosure and really address moisture responsibly? And so this is what we're trying to do. So then vapor drive is another issue. In the winter in the north, the drive is going out of the enclosure, and in the summer in the south, it's going in to the enclosure, to the inside. So you've got two directions. You want it to not get wet, but you want it to dry. Seems very contradictory, and in many ways it is. So this is a great quote from Anton Tenwald. I think that's how you say his name. So you need to assume that the building will get wet somehow at some point in time. Stuff happens, so you need a moisture tolerant design. Again, we're concentrating on drying, not just prevention of wetting, but drying. And so our motto, this comes from Proklima from Germany, is that freedom from structural damage or damage generally means that the drying capacity of the enclosure needs to be greater than the unanticipated moisture stress on the enclosure. And that's really defining robust building enclosure. So how do we achieve proper vapor control with all this complexity? Well, the first thing, as we know from the first part, is we want to make it airtight because air moving through the enclosure is the biggest thing of getting it wet, preferably inside and outside. The second thing is we want to maximize the vapor flow to the exterior while minimizing the vapor drive inward. One of the interesting things that we're grappling with the passive house construction is that because we're airtight, principally I think because we're airtight, the humidity levels in the houses are way above what we're used to. And so you've got a humid house to begin with, and we're finding even in New York and above, we're not that concerned about the inside drawing so much, unless it's a big house with empty nesters in it. But how to deal with the humidity. So we really want as much of the moisture to be able to dry out and not be driven in. So vented rain screens and roofs help dry out vapor open materials on the exterior, no foam. So the foam is not impeding the flow of moisture. and no vapor barriers on the inside. In the north, it was common practice to put a vapor barrier on the inside to prevent moisture from going into the enclosure in the winter. But we really want to avoid doing that because you're then removing any drying capability to the inside. So a few words, vented rain screen. The beauty of a vented rain screen. We have a blog post on it that my partner Floris principally wrote and I helped edit uh, recently. I encourage everybody actually to go on our blog. We regularly post um, pieces on it that deal with different parts of what I'm talking about here in specifics, and not just applying our products, although we do that, but things we're all grappling with in general in terms of building science, construction technique, and passive house construction. Um, so the vented rain screen blog post, beautiful thing about it, keeps the majority of the rain off the weather resistant barrier, keeps the sun off. So that solar drive you're knocking down, which is so important, especially as you move to the south. We don't want the solar drive pushing in, especially if we're going towards a vapor open assembly. We really want to kill the solar drive. Um, it mitigates potential problems from exterior reservoirs such as brick. If you've got a brick facade, you don't want to slam it up against the wall construction because all that loaded water in the brick can then just suck its way, or just you're basically putting a lake up against your building, making an underground building in a way. I might posit that. Um, so if the brick is vented as part of a vented rain screen, a truly vented rain screen assembly, then you can mitigate that issue. Provides optimum drying potential of the enclosure when it's cold. So again, in the winter, when it's the enclosures are having the hardest time drying, um, because you don't want them. The drive is to the outside. It's not going to dry toward the inside in the winter typically. So you want to help it go out. Um, and the vented rain screen does that. It helps maximize the performance and life expectancy of the waterproofing and the wind and air barrier. So that's a really important thing that we've mentioned before. You want to protect the air barrier. You want to protect the vapor control layers, and the rain screen does that beautifully. Here's that project again. Here it's hard to see. Uh, this is Orient Point, actually. Um, Bill Ryle is the architect, and David White was the passive house consultant on the project. Um, and so here's a wood siding rain screen over Solitex exterior membrane. So to the point of one vapor barrier maximum. Now, a lot of American roofs, typical American roof, it's a vapor barrier. So you're not going out. And so the important thing is, for goodness sakes, don't put a second vapor barrier into the assembly, because if you've got two, then you've got a potential reservoir area that will never dry out. It will just get caught and build and build and build. So a key thing, and where our products really come in and help with the Intello Plus membrane, is where you have the vapor barrier at the roof in traditional assembly. We want that assembly to be able to dry inside, right, while minimizing the wetting in the winter. It's a trick. So, so we're especially concerned about roofs. And also, if you're putting on significant amounts of foam on the outside of the building, on the wall enclosure, you would also have a significant vapor barrier on the outside. Although they say it's has permeability, but you really need to dry in. Know that you can dry in. Anyway, at a roof, the way uh, to address this, um, considering you don't have, um, say you have a vapor barrier on the outside and you have cathedral ceiling construction, dense packed cellulose, um, the vapor drive is going outside. That's the one arrow to the left in the winter, and the vapor drive is going inward in the summer. So in the winter time, we want the interior air barrier to be vapor closed and keep the moisture inside the space. We don't want it to get into the roof construction, which is the diagram on the left. In the summertime, we want whatever moisture may be in the assembly to be able to dry back into the interior of the house, and thereby drawing, keeping the assembly uh, dry. Um, Here we have the Intello Plus membrane on the roof here, taped. And so how we do this interior membrane is this Intello, this white membrane that you've seen in some of the photographs. And the Intello is an intelligent membrane. It's vapor variable. And what happens is from the wintertime, it's at 0.17. It's virtually vapor closed in the wintertime. And in the summertime, it can open up more than a permeability of 13. It's like 13.2. And then it sort of goes, that's for the test range, and then it goes even higher when you're out of the humidity range that it's testing, above 90%. It just skyrockets. So you have this huge curve between vapor open and vapor closed. So what it's doing,
Can I ask, is that just a result of temperature?
it's I'll go into it in a second, but it's a result of the relative humidity surrounding it. Um, the DB Plus is an interior air barrier as well, paper based, that does not have the curve. You can see a steep curve of the Intello on the diagram to the right. The DB Plus has a less of a curve. It's not quote unquote intelligent, but it can give you significant vapor variability um, uh, between winter and summer. So if you have clients that are really pushing towards like the greenest products possible, you can be like completely wood-based assembly construction with your air barriers and all. Um, so the Intello, uh, the intelligent membrane, it's reading. So we have two diagrams on the left. Uh, Two diagrams. The one on the left is the winter. The one on the right is the summer. We have roof construction. Um, they're showing, and then we have the roof structure with the insulation, and then the dotted line at the bottom would be the Intello membrane. And what you're reading is in the wintertime, average relative humidity of 40%, as opposed to the summer where it's reading about 80% humidity. And what the membrane is doing is with the humidity around it, and to the extent that the DB Plus has intelligence, plywood has intelligence, felt building paper, those things, their permeability changes from dry to being wet, and that's just a product of the humidity around it. What we get with the Intello, though, is it's an engineered uh, artifact that at a molecular level, what's happening is that if you think about it as a molecular conveyor belt of moisture, as the air around it's drying, the conveyor belt, sort of the molecules fall apart. And so it can no longer move the moisture along it. Whereas when it's more in a more humid environment, the molecules join up and the conveyor belt forms and it can move moisture. And so then it's going to move moisture in the direction of the drive, right? So it's going to go out or in depending on the season or your location, I guess. And the so the material is not unidirectional. It wouldn't matter if you applied it with the lettering facing you or the lettering facing the wall. Um, uh, the only reason to do it one way or the other is because of the finish of it. They've put a nicer finish on the one facing the space, so it's easier to tape and to work with.
Ken, could I just a question about your
Sure.
slide, not about
Sure.
the content, but could you just explain when it says the average environmental humidity of the vapor check?
Right. So
Vapor
check
is that the
this.
material? That's a
Yes.
smart material?
Yes.
Okay.
That's the intelligence. I'm sorry, this is not a
That's-
translated slide
That's
from
okay.
the
So that
German.
40% will be the humidity of the vapor control material, the smart membrane.
Exactly.
at those conditions, the 80% is what? That's
It's
exterior?
exterior humidity. Because it's cold outside, you have relatively high
Oh, so it's
humidity.
high relative humidity,
Right.
even if it's low moisture
Right.
content. And approximately 30%
relative humidity within
in
the
the wall.
insulation
Because
wall or roof.
the same temperature is, since the temperature has risen inside the cavity, the relative humidity has
Right.
dropped. And then inside it's at approximately 50, because that's what we're assuming is a good sort of middle point in that
Right.
wave curve of interior humidity.
Right.
That,
Given airtight enclosures.
right. Okay.
So if we were tipping with a typical enclosure, our interior humidity would be much lower, right? But that we're building airtight, we have a relatively high indoor humidity.
And one more question, then I'll stop
Yep.
so you can move on. Is it really driven by relative humidity, or is it moisture content?
The Germans, I can go back for the translation again, but we've asked them
Okay.
a few times, and they're describing it as relative humidity.
Okay. So
Yeah.
on a hot summer day, the relative humidity is lower. There's a lot more moisture in the air, however, because
Right.
it's warmer.
Right.
So the moisture content is much higher.
Right.
Therefore, so then it occurs to me that that could affect the moisture content in those materials, which at different temperatures obviously affects their relative humidity. But if there's a high moisture content or even
Right.
moisture pressure because of solar drive or what have you, that could affect these materials' permeability. But maybe I'm just like getting way
Yeah,
too
I don't know,
complicated.
honestly. Yeah, I don't know how it breaks down with the physics, to be honest with you.
Does anyone?
And with the different definitions, it's I'm happy to go back, and I can send go back to the company and my partners, and we'll send back a coherent,
Maybe
try to
we
be a coherent answer to that.
maybe we could just say this would be a good example of how I, as a designer, and you, as a
Right,
provider, would work together to sort this problem out.
right, certainly. Well, I think we just need to work to explain it better, so it's crystal clear to everybody.
But you do.
I thought the conveyor belt was getting us there, but
Or we could take this on faith and
It's all nanotechnology.
but well, we won't take it on faith. We ask nothing to take on faith, and like what we all love about Passive House is that the Germans first data um, uh, collected data endlessly on this and continue to do, and that it's a data-driven process and it's scientifically based. So Proclima is no different sort of an operation, and it's very data-driven based. And we'll look in a minute at a study that it did that shows a worst-case scenario and how the different membranes performed. But so this extreme vapor variability gives you the protection of to have in the wintertime when you want a construction to have a vapor barrier on the inside. It allows you to have through the Intello Plus a vapor barrier on the inside. But at the same time, in the summertime, you don't want a vapor barrier there. You want it to be able to dry to the inside. And the same material in the same spot is doing that. It's losing its vapor barrier characteristics, becoming vapor open, and allowing the construction to dry in. So it's giving you the best of both worlds, and thereby what it's allowing you to do is to choose not to put 6 inches of foam on your roof to protect the sheathing from condensation. So people that are looking to move away from foam-based construction, this is a material to help you do that.
And Ken, one last thing, since we're going into this great detail. The memory of this material, the memory ability to do this, that you're describing,
Right.
lifespan, like how long will it continue to perform it? Yeah.
Yeah, they see no degradation out. I mean, they've time tested it per their requirements out beyond 30 years. So we're not expecting any significant degradation in the lifetime of the building. I mean, there's not manufacturer guarantees to that extent, but that's basically the performance spec that it should, as well as the other parts of the building should perform. This should. So here we just show a little diagram of the Intello, the DB Plus, the dry cup. So we have the relative thicknesses, the dry cup dry cup permeability. So you have the Intello at 0.17, the DB Plus at 0.8, so it's significantly more. Polyethylene, which is our plastic sheet, which is dead closed, and then plywood OSB, and then wet cup. So the Intello is going way up to 13, maximizing the drying. The plywood, which also has the DB Plus is going to 5.5, which is it's nice, it's good. It's not as robust as the Intello, but again, it's not it's not a polyethylene copolymer that the Intello is based on. It's all natural material. And then the plywood.
Solitex isn't on there. Does that
The
have a similar?
Solitex, right? These are all interior airtight materials.
Okay.
So the Solitex is perm of uh, 33.
Okay. Very good.
Yeah.
And one last question: is there,
Yeah.
is there an easy way to determine when you need an interior air vapor barrier? Is it just a
Right.
question of winter temperatures below a certain point?
Well, in terms of a vapor barrier, they're recommended. Folks recommend it if you don't have exterior insulation. Um, Outboard and you're in the cold climate. You're in the heating climate. But the problem is that when you have the vapor barrier, but the code just says retarders actually, and a lot of things can qualify as retarders. So the vapor variability and the requirements of the retarding and having a vapor, I mean, vapor barrier is what was somehow ended up being traditionally done. It still seems to be a mystery as to why, even to the experts. Um, uh, so it, there's the makeup of the assembly. The bottom line is a pretty complicated thing. So what we're talking about here is just general principles and directions of
but
which way to go.
as a general rule of thumb, any heating climate, this would be.
A lot of heating climates, in the northern climates, you wouldn't necessarily need to have a vapor barrier in the winter. You could have perfectly robust any number of ways of doing it without it. The thing that, yeah, we'll keep
Well,
going.
maybe you should. Maybe you can finish answering this question, but I think the problem that we have here potentially is taking questions from the audience in the middle of the presentation is one. I started it, so I'm at fault. I apologize. But the problem is one, we're not going to get through it. We're already at 40. We're probably already at an hour. And two, the people listening online can't hear the questions. So what I'd like to do is have a formal question and answer period where I actually repeat the questions so that Ken can then answer them. So these are all
Sure.
awesome questions, and I'm glad they're being asked. But
Yeah, absolutely.
at the moment, we should probably push on.
Okay, we'll come back.
I
We'll come back.
apologize.
No problem. So here we have, this is a picture of the mock-up. It's actually a mock-up that's in the room. And so what we're showing is on the right is the interior side of the construction. On the left is the exterior side. And we have Intello going around the interior of the window pocket, acting as the vapor retarding membrane. Again, retarding in the winter, open in the summer, uh, with tape going around. And this is the tape that you would apply to the window frame before you install it. It's Contiga SL. It has several tape surfaces. It's the blue and white tape on the right, the vapor retarding airtight tape. And then on the left, we're vapor open, and we have a vapor open tape called EXO. So you attach the Solitex Mento material to the window frame with a vapor open tape as well. So around what we're trying to do with this particular slide, one of the I should say, one of the biggest areas of concern about condensation is oftentimes around window and door frames, where condensation and mold and rot will occur. And so with such an assembly on the left, where we're making it as vapor open as possible, any moisture that does happen to get in there can get out to the exterior. And on the right, to the interior side, we're controlling the vapor uh, from getting into it with the intelligent membrane, and letting it dry to the inside as well. So we're trying to keep the space around the window as dry as possible. So This is the part, not to take our anything on faith, very science driven. And so Proclima did a whole series of studies, and they continue to study. I'll show one slide, but so they did a study with the Woofy 3.3 Pro, 1 year study at 1 hour intervals. They loaded the structure with moisture initially. Um, and then they located it in a place that was difficult. So in high altitude, they did it with a north-facing roof structure, and then they compared different membranes and different permeabilities. So they had a PE sheet vapor barrier, a vapor constant retarding membrane, which is it's roughly the characteristics of OSB equivalent, the BD plus, and the Intello. And there's a whole series of graphs, and I'd be happy to send out the brochure and study. You can actually, I believe you can download it from our website, but I certainly will email it, PDF of it. But we have one slide. This actually the worst case scenario slide, I guess, just short of a green roof. In terms of moisture vapor control and construction, rule number one from everyone that we talk to is don't do a green roof. Um, they're really hazardous to your assembly construction in terms of moisture. That's uh, that's the word that we're getting from the Europeans, from different Americans. So this is the next. If you're not doing a green roof, if it's a pitched roof, if it's facing north and you happen to be at a high altitude, uh, you see the water content, and the red line is the plastic sheet. The yellow line is the OSB equivalent. The dark blue line is the DB plus paper vapor variable membrane by Proclima, and the brighter green line is the Intello plus. So you see very aggressive over the years. Again, you're starting at a high moisture content, and in very difficult conditions, climactic conditions, it's drawing. The assembly's drawing and drawing and drawing over the seasons. So very robust assembly. So you have, again, the Intello Plus on the inside, with this protected by a service cavity. The Solitex Mento and Plus could be on the outside, preferably protected by a vented rain screen. Gives you very robust. And so what we're trying to provide with this is just a complete air sealing system that gives you the most uh, uh, control over trying to deal with moisture issues, the vapor properties of the assembly, and robust, long-lasting, durable construction. So that's Proclima, um, and what we provide. And we really enjoy looking at projects and going in and seeing all the different variables. And oftentimes, there are a lot. It's a little overwhelming when you go on the website. There are a lot of different tapes. There are a number of gaskets, a number of primers, caulkings. We can work with you, narrow that down, have a palette of materials for a project. So you're not like stocking a hardware store to do your airtightness. Typically, what we're seeing, I'll say, the tapes have a wide range of cost variability. Um, the, uh, the workhorse tape is really much on line with the 3M split back tape that many people use, the flashing tape. But some of the specialty tapes go more expensive, but other tapes that we have, interior tapes, are less expensive. The membranes are going to be on an order of magnitude of several times what typical house wraps would be, but it's sort of apples and oranges at that point. That's for another lecture. We could go through the technical properties of traditional American house wraps and the, the, the weather-resistant barrier, the Solitex that we sell, um, uh, and so what I would say is that in terms of cost and price, while these are very uh, high-performing um, products and systems, that for a typical modest house, for the membranes, tapes, caulkings, whatever you need, a few gaskets, you're looking at an order of magnitude of a few $1,000s. $3,000, you should be able to do it for a modest size house. We're not breaking the bank, and with that rather modest amount of money, even though it may be disproportionate to traditional American materials. You're really investing in some of the most important aspects of the building construction. Um, we work, and I should say, we work with builders, builders, architects, engineers, design builders, homeowners, and working through details and everything. I'm happy to work with you. So, very briefly, a couple of other products that we do. Skylights. So this is a skylight from Poland, triple glazed, wood frame. It's about a R7 installed. It comes with you can order pre-made curb. It has a really nice exterior shade, so you can knock down the solar gains. That's easily retractable. I have 3 in my own house. I love them. They work really well. This shock Isocorb, we're just sort of referencing this. This is not a core product, but something we want to help spread the word about. And so uh, we sort of have a dealer agreement with them. Cantilever thermal brake material for concrete cantilevers. And then this product we love very much. This is a through wall, high efficiency heat exchange ventilation system, decentralized. So this Lunos, this is another German company from Berlin. Um, you install these units through the wall in pairs with a single controller. It has over 90% heat recovery efficiency. And how it does it is one is supplying air to the space, while the other unit in the pair is exhausting air from the space. As one is exhausting the air, the heat is being transferred from the outgoing airstream to a ceramic core, which you see in the photograph on the right. That waffle-shaped thing is a specially manufactured, designed ceramic core that retains the heat. After 70 seconds, they both reverse directions. So the one that was exhausting is now supplying, and it's transferring the heat from the ceramic core to the incoming airstream. Uh, and so these things run in tandem continuously. And they're running at about, the typical setting is 18 or 20 CFM. It's very low volume, but for a small apartment or small house, you can ventilate it with, 1, 2, 3 pair of these things. And we have examples where folks are doing air tightness and high performance retrofits, not necessarily passive house, and they've gotten more airtight than they imagined that they could, and they realize that they need to ventilate their house. So this is a really nice way to come in after the fact. You don't need to open up anything and stick them through the walls. You still have to run some wires to connect, but much less than running much less invasive than running a centralized ventilation system. Uh, so we're excited about this. It's quiet, wonderful. And then we have the Magic Box, Compact P by Neelan, which is a Danish uh, company, and we're in the middle of testing this right now and bringing them into the country. And the Magic Box does the ventilation system, it does the hot water heating, and it does space comfort heating and cooling. Combined, we're seeing that with the prerequisite is pretty much it needs to be a modest size house. It needs to be a passive house level construction. If you're not building to passive house, you can't consider this. Um, and with that, it can be an appropriate device and really take care of everything in one sort of refrigerator-sized appliance. Uh, and one is going to be going into, well, a couple probably are going to be going into Vermont into a couple of passive houses later this year. And we're finding even in that harsh climate, given the passive house construction, combined with a brine loop, ground loop, um, uh, it can handle everything but the most extreme uh, days for the heating. capacity for the space heating. So we're very excited about this product. There's my diagram, and that's it.
Good.
So I appreciate y'all having me, and I'm happy to answer any questions.
All right, so thank you, Ken. That was incredibly helpful and informative. These are really exciting mock-ups. It's really fun to see them in person. The pictures are great, but boy, I think anyone who can get to Brooklyn and see these things, you really got to check them out. Okay, so we are at an hour, more than an hour, because I tried to mess with the screen and reset the clock. So most of us are all still here online. We've only lost a couple folks. So I would ask you to submit your questions now, so we can get them going. In the time it takes you to type them in, I will probably ask a question of my own to get things rolling. So hang on one second here. I just want to make the questions visible. And I think what I'm going to do, folks, is take the screen off. You'll just see the cover slide from the beginning of the presentation, but we're still here and still talking. And then if we need to, we can go back and Ken can get one of his slides up again to answer a question. So with that, we still have voice going, and I'm going to try to answer the questions or ask the questions so that you can all hear, and then we can get an answer from Ken. I'm going to just monkey around a little bit here to get my screen so we can see the control panel. Sorry for the rough transition here. So Ken, my first question is, how many times do you have architects just say, well, I'm an architect, and so I like to have sheathing and everything on both sides of the wall. I need it to be really bulletproof, even though they're making it less bulletproof.
By putting
Well,
foam? Or...
No, I mean these having no sheathing, having just membranes. It, when I first heard that, I thought, wow, really? And then when I talk to architects, the first thing that I hear is, well, I can't do a floating slab detail because I really need to support the structure. Never mind the fact that you and others have studied, sub-slab mineral wool insulation. Katrine's done floating slabs. There's an incredible amount of conservatism out there, which is warranted. We want to be careful.
Right.
On the other hand, there are an awful lot of legitimate uses of materials that are sort of ruled out. So just as it's sort of a silly question, but
no, it's good.
But it does seem like, how are you dealing with sort of the natural skepticism of the design community?
Right. Well, certainly, I would say two things off the bat. It's certainly an evolving process, and it's an education process, as we're all seeing with a lot of the passive house elements. So working with the architects, I mean, even more important, if talking about sheathing, is often a structural, and even more conservative structural engineer standing behind them. Right. And builders and having the way they do things, and they're comfortable doing things. And then you have the inspectors and the building officials, and from jurisdiction to jurisdiction, one thing may be acceptable or not. So it's highly variable. And I'll just say, we try to address each situation uniquely and nudge it, and take each project as far as we can and declare victory, and go on from there. I will say though, while one of the mock-ups that we do have here, and there was an image that we referred to in the presentation, is sheathing free, meaning there's no OSB or plywood of any sort on the interior or exterior of the stud. It's a double stud wall construction. We see that as a really desired goal and a direction to go in terms of resource sustainability, and just an elegant way to build. But certainly, virtually everything that we're dealing with has sheathing, and we're happy to work with sheathing. One of the mock-ups that we have here with the window in it that we couldn't see in the presentation from the slide, but we can see it here, actually is using plywood sheathing as the air barrier.
Right.
We're not even using our product for the interior air barrier. It was with the construction is an interesting one. I think it's one that Katrine definitely promotes well. I think Chris Corson in Maine is worked with is basically having a stud construction, interior construction 2x4, 2x6, whatever it is, with plywood sheathing. You basically have a plywood box house, and that plywood could be the air barrier. Then hang TJIs off of that or Larson truss.
Right.
Do dense pack cellulose. And then what we're looking to do is rather than hang sheathing off of that, then do just the membrane, the Solatex Plus membrane.
Very
so we're
good.
trying to keep it variable.
Okay. So we have, I'm sure we have questions here, unless we got them all out of our system earlier, but we do have one from an online attendee. So I'd like to ask that question, and then I have a couple more. Those of you who are listening, please type in your questions and ask them now, because we're all probably hungry and we'll probably, be done here before too long. So send your questions in if you have them. Okay, so the question is from William Otto.
Bill.
Bill, you know Bill?
I know Bill.
Okay,
Hi, Bill.
hi Bill. For many home energy efficiency retrofit projects, exterior wall insulation using EPS or XPS is employed. Wouldn't this situation trap moisture, and if so, what do you recommend, i.e. airspace beneath the EPX, and or what product that I assume he's asking,
Right.
what product that you represent would resolve this?
Right.
So I assume, Bill, you're referring to exterior EPS or XPS, and so wouldn't that trap moisture?
Right. Right. So, I mean, and that's a very standard way to retrofit a house for greater performance is to wrap it in foam sheathing. Um, and, uh, and so it depends on the wall construction. I mean, in and of itself, yes, the answer is yes, it does trap moisture behind. It's not going to be generally as permeable as the the wood construction that it's either taking its place or is covering. So we'll trap moisture, and so you're creating a moisture issue that you then need to figure out and make sure that you're mitigating. Maybe the construction mitigates it well enough, or maybe it doesn't. What we would like to see instead of wrapping a house in foam, and everybody uses foam, understandably, for the reason that it's the greatest R per inch. But once you get beyond that argument, we see no other reason for it. So what we'd like to see is if in a greater balance of goals is to wrap the house. You could wrap it in rock wool, and like one of the constructions that we saw here, where we have a typical wood stud construction with plywood sheathing, then put several inches of rock wool, wrap the house in rock wool, and then wrap it in Solatex Mento, airtight, watertight.
On the exterior of the rock wall.
Yes, on the exterior of the rock wool.
Okay.
So the outside face of the rock wool is then the weather barrier and the air barrier protecting the rock wool. So your insulation is optimized.
And you're not getting the moisture in against the sheathing because it's not coming through the rock wool, which of course is very open.
Right.
So you're protecting the outside.
It can dry out. It's keeping the rain, the wet off of it. It's waterproof while it's still vapor open. And then do the rain screen on top of that. Because if you need to create an air gap behind the XPS or EPS to mitigate potential problems about moisture, then you're sort of defeating the whole purpose of wrapping the house in foam in the first place.
Yeah, I was just at the Building Science Corporation Building Science Seminar, and their solution was essentially to make it as bulletproof as possible by putting a ton of foam outside the framing and sheathing so that there wasn't a condensation risk.
Right.
But that literally implied bulking up. In our climate, it was at least a third of the insulation outside the framing, which can be done, but it's not always easy, and it usually implies foam, or because it'd be harder to nail through mineral wool at that thickness.
Right.
So they were actually coming up with solutions. Then they had a double weather barrier under the foam and above the foam. So they had to just keep adding materials and tapes and cost. Whereas I guess what I see is the potential for having more, as you said, moisture tolerant assemblies as opposed to just layering on lots and lots of foam, which I think has its own impacts. Alan, you have a question?
Well, a follow-up to that is a question of how does Solitex handle bulk water? What if bulk water were to get in behind or to the
Right.
interior of the Solitex?
So the
to
question,
drain it?
the question was, what happens if bulk water gets under the Solitex, which is this exterior membrane that Ken has before us and showed in the presentation?
Right. And so if you have a, a bulk water leak, I mean, then you have a water leak problem, and it's not no material is really going to dry fast enough to compensate for that. It will allow the vapor to dry out. It's still a waterproof material, so it's not if you have a bucket of water behind it, literally, it's the water is going to stay there. So you need to deal with the water leak. Definitely, you're not going to. There's no way to really. Drainage is the only way to deal with a bulk water intrusion into an assembly. You're not going to get rid of that through vapor diffusion. What you can prevent is the bulk vapor.
Yeah.
So if it's the bulk vapor, the bulk water through vapor, through being carried by leaky air that we saw with the 33 quarts over the heating season, um, that is still, in terms of the assembly, a manageable, well, I shouldn't say whether it is or isn't, but what we're talking about is it's still a magnitude less than if you have an active leak from the outside, right? We're not, does that make sense?
Okay. Well, that said, and understood and accepted, uh, we've just become familiar with this rock soil product
Mhm.
for exterior insulation.
Yep.
And haven't even tried it yet. But if I'm not mistaken, the detailing from rock soil shows the weather resistant barrier to the inside surface of the rock soil.
Right.
So,
Well, they may show it that way in terms of
yeah.
The ease of their like dealing with their products, but we want to see the to max. It's kind of a funny thing, and we'll look at that those diagrams because to optimize the actual insulation value of the rock wool, you want the air barrier to be outside of it.
Keep it dry.
Well, you want to keep the air currents out. I
Air
guess
currents.
it could be get wet essentially and still operate, and that's what they're demonstrating really. It's
Yeah.
like so around
Well,
a foundation of a building.
That it is freely draining.
Right, and so around a foundation of a building, you can put the rock wool, and it can sit in water, right, and still function as insulation, more or less. Um, but in terms of the air passing through it, that's compromising the insulation. So there's kind of two different things. So from the air tightness perspective, we want an air barrier on the outside of the rock wool, and so then once the air barrier is on the outside of the rock wool, we want it vapor open to let any moisture out. And then at that point, we say, well, let's make this the waterproofing layer as well because we can.
Um, okay, so
I suppose I wonder just to add. I don't know. I don't want to. One might be able to imagine a scenario where you do have the water control layer behind the rock sill, but you still have an air barrier in front of the rock sill. But with our material, that would be redundant.
Yeah.
The air barrier would take care of the water as well. So I guess we need to get in front of rock sill with our material.
So I had a question sort of related to that, which was that if we have the Solitex on the outside, and that could effectively be an air barrier,
Yes.
do we also need the Intello Plus on the inside? And I think what I'm understanding from your diagrams is that we need to manage diffusion in both directions. So it would be advisable to have it on the inside. So is that a fair answer to my own question?
Um, well, I would just elaborate and say that it's a matter of degree and it's a matter of robustness and how far one wants to go. So, and in terms of optimizing the the systems. So, one air barrier on the outside can work and can work perfectly well. But if you have an air barrier, if you have a fibrous material like cellulose or rock wool, if we put an air barrier on the inside of it, we're going to have even greater performance because we're going to eliminate any issues of convective currents through the insulation and forgetting about the vapor, assuming it's a vapor open construction on the inside, we're going to eliminate any wetting issues caused by air movement. So that because if we just have the air barrier on the outside, you have the humid over 50% relative humidity interior air still getting to the air barrier, which is on the outside.
Right.
So it depends on your climate conditions. It depends on a lot of things. So in terms of, and the guys at National Fiber and other cellulose companies will tell you that they're using cellulose now, switching it slightly. Very robust material. It handles a lot of water, and you can go a great distance with it without. They'll say even in a cathedral ceiling, if you have a vapor closed assembly on top in the roof, um, that the cellulose will handle it. You don't need to worry about putting, I don't think I'm putting words in their mouth, putting a vapor barrier on the inside. The cellulose is so good at managing the water that there won't be a problem. While everybody in the building science community generally is like, this is a recipe for a nightmare scenario. So where we're really concerned about this, which we are concerned about it, and the National Fiber guys and the cellulose guys generally are as well. Um, uh, at the cathedral ceiling assemblies where you're vapor closed on the outside, the Intello gives you that added robustness of being vapor closed when you want it and vapor open when you want it again. The wall assemblies are a whole nother magnitude of sort of moisture tolerant design. So the roof assembly is sort of the worst case scenario in terms of moisture because you've got typically you're going to have the vapor closed on the outside unless you're doing a vented roof, which we'd love to see, and hopefully we can get construction going in that direction. Oftentimes the wall assembly, you don't have a vapor closed outside. Um, and uh, so the wall assembly itself is just much more moisture tolerant. So while for air sealing purposes, and for any number of reasons, and I could go into it for some time, it still makes sense to use the Intello Plus on the walls and the roof. For moisture, concern about moisture and vapor issues, you know, we would recommend if you had to make a choice, put it on the roof, and you could do the walls with just latex paint on chipboard, which is what standard vapor retarder is.
Okay. Very
That
good.
makes sense.
Good. Yeah, it's very helpful. Do we have any other questions here? I have a couple more questions. Go ahead, Greg.
With stucco as an exterior finish,
Right.
traditional cement stucco. Is there a good method that allows for breathability? I mean, does it just is any words on that?
The question regards the use of stucco as an exterior finish material and how Ken would respond to that with materials he handles.
But not an ethos.
Not an ephes,
Right.
cement stucco.
Vapor open, relatively vapor open. Right, not acrylic where it's trapping the vapor in. Yeah, I don't see the only issue that we see with this where it's of concern, especially in the airtight houses that have high humidity to begin with. Is this stucco assemblies if you have solar drive and moisture, depending on what the conditions of the site are or the climate, how much moisture you can drive into the assembly and not have an issue. But I mean, inherently, so this is something. So because the building itself is in a way with the airtightness and the passive house construction, we have created this situation where we do need to be more robust in our thinking about dealing with the humidity and moisture issues. So the stucco, while it's been traditionally used widely, no no issues done properly. I don't know that why it shouldn't continue to be the case. I would say in terms of our products on the outside, we have no real application there, um, because you're going to be using a mass wall construction stucco. What you can see is to help alleviate that is to put the Intello on the inside, just so that again you're guaranteeing air tightness in a way, so you're not adding to the problems through any air travel with moisture, and you are to the extent possible uh, not again allowing it to dry to the inside without adding moisture to it from the inside. So we're trying to mediate that.
Would one of your exterior products be better than another as the fact that you have a stucco?
Behind the stucco, well, they're all permeable.
But all the penetrations for the attachment of the lab.
Right. Well, I would say at that point you're not. Well, you're putting stucco on. You're not putting stucco on masonry. You're putting stucco on wood frame. It's a whole other can of worms. I think that's another session.
Maybe that's a can of worms that you guys can get into after we sign off,
I would
or
say
we can do another presentation on masonry constructions and stucco finishes, etc.
Yeah, I mean, my final thought I'll revert back to make a traditional stucco construction as a vented rain screen.
Yeah.
Wow.
Modify it so
Yeah.
it has that high performance capability.
I think that's a good idea, and it's clearly a conversation that could go on for a while. We do have one more question online, and then I have a question that I'd like to ask to close out. So our next question is from Daniel Roy, and the question reads, what do you recommend for double wall construction with cellulose with regards to an air barrier? Common to see zip wall exterior as an air barrier. Do you have any comments on this? So we have a double stud wall mock-up here in the studio, and there was one in the presentation, which you will all incidentally be able to find recorded online at the Passive House Alliance website once I figure out how to upload it. So give me a little time there. But so to the point of the question, if you want to see the wall section again, you can see this recorded online, and now Ken can tell you what sort of what about zip wall as an exterior air barrier, and what would you recommend for a double wall construction?
Right. So recommended for the double wall construction. Our dream wall for the double wall construction, is this one that we had one or two images in the presentation. We have the mock-up here. Is a double wall construction without plywood or OSB or any type of sheathing on the inside and outside. That you have on the inside, you have the Intello Plus airtight vapor variable, vapor intelligent membrane. On the inside of that membrane, then we have horizontal 2x3, let's say, strapping as a service cavity, and then you're mounting the gypboard onto the horizontal strapping, and that way you can run the electrical and plumbing and everything through an exterior wall without penetrating the air barrier, and allows you to in the future hang pictures and do all sorts of things to the wall while protecting the air barrier. On the outside of the double wall construction, then with the sheathingless construction, we have the Solitex Mento Plus, and the Plus, like the Intello Plus, is reinforced. And what's nice about the Intello Plus and the Solitex Mento Plus, with the reinforcement, they can handle the dense packing of cellulose behind them, and it's built into it. So when you're putting in the cellulose, you don't need to do the the typical the mesh that is used with the blown-in cellulose. You can remove that from the sequence. So you have the Solitex Mento Plus on the outside, which is a fabric membrane, very robust, again, waterproof, vapor open, airtight, and then you put a vented rain screen on top of that. That's our ideal recommendation. Now, backing away from that, you could certainly put plywood or OSB sheathing on the outside, um, and we would just say that you could tape that you could just tape the joints of the plywood or the OSB, and do it that way. Perfectly, one way to go. We would certainly like to see it wrapped in the Solatex because we feel like it's going to give you, again, a more robust performance. You're doing it once. And so in terms of the taping and the penetrations and tying into the windows, it's going to ultimately be quicker and more robust installation. Um, Ideally, again, we want to see an air barrier on the inside as well as the outside of the cellulose. So you're maximizing the cellulose. So even if, let's say, you're doing the zip wall construction on the outside, which I don't really have an opinion on, I need to honestly delve more into the specification details of it. But so I'm not going to really say anything one way or another about the zip wall, but widely used for air tightness. Obviously people are getting the air tightness out of it. I think in terms of vapor performance, there may be a question about it, but again, I have to read more about it. And even if you're doing the zip wall on the outside, we still, again, would like to see the air tightness on the inside, and we'd like to see it with the right moisture control. So,
Okay, great. We have another question from an online attendee, Timothy Lin. When placing a foundation on structural foam, do you recommend placing the foam below or above the vapor barrier, and why? It doesn't really necessarily relate to one of your products. So maybe this is, I'm not sure we can put Ken on the spot for this, but.
Yeah, no. It's always, the foundation questions are always a good one. And believe me, we always end up, when we're talking with contractors, architects, engineers, digress into all kinds of stuff that has nothing, that is slightly off the direct thing. I do think, yeah, so I'm not going to,
Okay.
we'd be happy to carry the conversation outside, but right now probably shouldn't touch it.
All right, take it outside. All right, so I have a question, and I think it's probably time to wrap up. Barring any further questions, if you have one, please get it in at this very moment, or forever hold your peace.
Well, I guess in terms of the vapor, it was on subject. In terms of vapor control, it was on subject.
It's on subject, yeah.
But
maybe not in terms of a material you're talking about. We haven't really talked about foundations. My sense is that you don't really need to protect the foam against vapor. You need to protect the slab against the vapor.
Right.
So it may not really matter.
Right. So put the vapor barrier between the foam and the concrete.
Yeah.
Right. I mean, you see that a lot where
you're going to protect that barrier from being punctured or something against gravel or whatnot by putting it between the foam and the concrete.
Right. Exactly. Put down the gravel, then the foam, then the vapor barrier, air barrier, which is going to be the same. You see a lot of pictures of passive houses where the vapor air barrier is going in over the foam
and then pouring on top of that.
And they're pouring on top of that.
I
think that would extend to the footings as well.
Right, but no implied warranty or guarantees. No lawsuits, please.
That's not an official recommendation.
This is like doing online medical advice. You go see your own doctor.
There's two thoughts on that. So
there are multiple thoughts, I'm sure, on every topic. Let me give a final question or comment, and we're going to wrap it up. This has been fantastic. We still have most of our attendees, so everyone is obviously still interested. All right, so here's a question and comment. They're sort of intertwined, sort of a dual question comment. Okay, so I said I was at the building science seminar a couple weeks ago. Really fun.
Yeah.
Lots of questions.
I recommend everybody take
everyone should do it, and everyone should remain skeptical and ask lots of questions.
Right. And don't take it personally when they rant and rave about
sit in the front row because they need someone to pick on. So I did that. I sat right up front, and they will call you a loony and a freak, and they will like heap piles of scorn on you, laughing all the while. And as long as you smile back, it's okay. But in doing so, you need to maintain a healthy amount of skepticism because no one knows all the answers.
Well, and they're in love with foam.
And they love foam, right? Although Mr. Straub is definitely willing to at least acknowledge the environmental impacts. Joe, not so much. But in any case, that and Martin Halliday's recent article on the much ballyhooed failure of the Belgian passive house. Now, I'm going to go out on a limb here. Martin, if you're listening, please give me a call. I don't see you on the attendee list, but I have a bit of a a journalistic integrity bone to pick with you about the issue of the headline being radically different than the content of the article, in that it said passive house fails, and it leads off with Katrine Klingenberg's house as an example, while in the content of the article, it talks about a reservoir material over a vapor open sheathing,
Right.
resulting in interior OSB rot and very serious health and safety concerns, all of which are important things for us to talk about. But in referencing vapor open material and Katrine's article, it makes it sound like the OSB is inherently a bad thing and vapor open is a bad thing, where really the issue, in my mind, is that there was a reservoir material that was not vented and a ton of solar drive. So we all have to be really careful in reading these articles to determine what the risk factors actually were. So, but related to that, let's assume Martin, he raises good points and generates a lot of good discussion. My question to you is there actually a scenario in which we really don't want to be vapor open? Now, Martin's example is perfect, but who wants to build a reservoir cladding without a venting space, without a working vent behind it? So anyone who does that is going to run into trouble regardless. But is there a scenario where you really do not want to be vapor open and allow the vapor into the wall assembly at any time?
Well, I think I'm sure there is beyond my building science knowledge. Frankly, I will say that I know in pool structures and high humidity interior environments, definitely required, and tricky assemblies. In terms of exterior climatic conditions, I would, my gut is saying, and I'm not the professor of this stuff, is saying that you can successfully build vapor open. You just need to, again, like we saw in this article in Green Building Advisor, need to be very cognizant of the assembly and how the parts and pieces are going together. And you can't take a difficult situation and make it an impossible situation. And another thing that struck us about the article, and Martin, if you are listening, I didn't bring this up. Michael brought this up completely unprompted. Not that I mind. I actually exchanged emails with Martin offline about the article.
You can defame me online instead of.
I was just like, oh my gosh, what is it? Anyway, it's a provocative article, it seemed like the building was probably. You're exactly right in having a reservoir material up against the OSB. It's not vented wall construction. If they'd done a vented assembly like we're talking about, it would have mitigated a huge part of the problem to begin with. It could be quite possible that the construction came loaded with water, that the OSB was already wet.
Well, I think he in the article actually went on to say, if you have this much reservoir cladding and this much sunlight and this much heat, you have this much vapor drive, and he explained basically what the problem was. But that's just not what the headline said. So my concern is
how he set it up was completely.
He set it up to malign A, passive house, B, Katrine's house, whatever. But my concern is that, right. But I guess my concern there is that a discussion about how inadvisable vapor open could ensue, which I don't think is the case.
Right.
So that's the point of my question and my concern. Right. And I also know that any question I ask of that nature would have to be answered on a case-by-case basis. Right. But I think it's worth at least all of us being aware that question is not as cut and dried as that article or other discussions would make it out to be.
Right, I agree. And I think it's important to note that when we talk about vapor open too, we're talking about an assembly that has vapor retardation, if not out and out closed, every step of the way. So whatever assembly we're looking at, it's a complicated thing in terms of the vapor profile. So, if anything is useful with the GBA article, it's that, we all just need to really double check and triple check our assemblies and how it's marrying up to the rest of what the building's doing. And I do think the article, and along with that, because we are with airtight houses, I've said this too many times already, but one more time, the relative humidity inside these houses is much higher than we're used to. and so we're coming with loaded houses in a way, and so we need to be cognizant of that and be more robust than we would necessarily think we need to be.
So that's
Protect ourselves.
a good answer, a good overall message, I think, for today. It has been quite a long session, so we're gonna close it here. As with all passive house or building science related discussions, if we went and found a beer, we'd keep talking for another 5 hours. But
Let's go.
let's sign off. So from beautiful Tacoma Park, Maryland, and the offices of Abrams Design Build, this is Michael Hindle from the Capital Chapter of the Passive House Alliance. Thank you all for attending, and this will be posted online at the Passive House Alliance US website as soon as I can get it up there. So you can find it there again, and I know Ken will entertain questions and phone calls via email, etc. So thank you for your attendance, and have a great weekend. Bye-bye.
Thank you.
Bravo.